was PT, and yesterday we have solved a huge problem. A is going to B, B is going to C, and a C study. So after that we had one problem on the network, tank network. Have you developed the differential equation for that? I asked yesterday. Any development? Is there a development? Because there's a simpler problem which I compared to the problem what I solved earlier. Simpler problem what I solved earlier. In development from your side, what is the system? It is Ax equal to x plus b, right? The last problem was, see, I am not asking to submit the assignment. Even the trying part, attempting part also I am not doing. I don't know what kind of business is there in your mind. Of course, I understand you have come here for business because you have cracked GATE exam, you can, your next step is crack GATE exam again, get better score and go. That's a good business. But as long as you are coming to the class, you go, you are not sure actually will be cracking GATE or not. That's another thing. If you are not, then you have to continue the MTech program. And that's a big problem. If you do a badly in the courses, because core courses are very important. Okay? If the core courses are bad, then your CGPA will be bad. Because core courses are 4 grade lectures. Other courses are only 3 grade. Because if you can't get fine, you will go home and you will go for job fine. If you don't, then you have to continue the MTech program, and MTech will give you the good job also. But in that case, you need to have very good CGPA to get good job. Okay, so it seems you are not interested to do that. So shall I skip this problem? If you say I can skip, no problem, I can skip the problem. Because you are not interested. Yes, I am not asking for submission of assignment. Even the attempting part you are not doing. So this is really something I am unfortunate to see that kind of incidents. Because I take pain to teach the class. And some of you guys have been seeing that you are even not caring even to bring the assignments. Okay? That's the kind of thing. You don't have assignment problem, right? That's the thing. You don't even care to bring the assignment. So that's I see them as my situation. And if I teach bad, you will go and tell that the teacher is teaching bad. So teachers should do everything perfect. Students can do anything. That is our country. Vasudha don't have assignment also. Okay. Who doesn't have assignment in that bench? Who doesn't have? Who don't have assignment? You also have? You all three have the assignments? Okay. Both of you don't have the assignments. Excellent. That's the way. That's the spirit. So people are not, I'm seeing in the front bench itself, so many people are not doing even assignments. So that's the good spirit of the class. Okay? And remember that, this thing is the question has been set up is very easy. That does not mean the getting also will be easy. The getting will be difficult, the question is easy. Okay? And, of course the people who are will be sincere in the class, they will be paid by their grade. But the people who don't do anything, I cannot give any kind of mercy. Okay? So we have the new grading policy from this year. They told that, you should not be liberal too much for the grading part. If the people are honest and do a good job, give the good grades, otherwise not. Because this place is not the time first place. So the new policy has come for the grading policy from this year onwards. I'm telling you that earlier years I was very liberal, but I told that you should not be liberal because this place is not the time first place. If you do time first, you will be getting paid by the grade. And don't think that my point is the meeting we have evaluated the MTech situation. It has been decided that okay, MTech guys are coming mostly for writing the GATE exam. If you crack the GATE fine, you will go for job. If you don't, think about that part, the gambling process. And in spite of that, if CGPA is bad, you may not get a good job because only first 10 or first 15 will be assured to get job. Top 10 or top 15. After that, here's a question. The senior is also here. Senior can give you answer. But thing is that since many people are actually writing GATE exam, it has been told to us we should not be liberal for the grading policy. So my grading policy will be much different from the earlier years, and I cannot be giving so much of part marking. So in that case, the chance of getting C, E or E, even U grades will be much higher. So be careful. I'm just telling you priori. I should not be telling all those things about confidential meetings and the confidential outcome, but there will be very high chance to get C, D, E and U grades. And if MTechs get a very bad grade, even if you crack GATE fine, getting GATE means that you have to have top 100, top 200 ranks or something, or top 300, whatever. If you won't get it, you have to continue the MTech program here. Your nuclear is less, that means you are completely gone. You are neither here nor there. So be careful, because my grading policy will be really, really difficult this time. Questions will be easy, because that's the way I follow the district policy. Questions will be easy, but I will be ruthless. If I see that you are not there, I am not allowed to give you part marking. In that case, disaster will be there if you are not giving the right answer. Okay. So, anyways, so anything from your side? Any of you could get the differential equation, which is dx dt equals to what we are going to get, dx dt equals to ax plus bt. Okay. What is that? X vector is h1 and h2. X vector is h1 and h2. X vector is h1 and h2. So what is A matrix? Minus 2, 2, 1 minus 3, and what is B vector? B vector is 1, 0. So this kind of problem also is interesting, because since we have a non-homogeneous part here, we can directly get the steady state like this kind. So in that case, if you get the steady state Ax plus B equals to 0, you know the A matrix, you know the B vector, and if you can do the eigenvector expansion without solving, you can get the solution. And one of the eigenvectors for this too is a non-symmetric matrix, and the eigenvector is U1 and U2 is orthogonal to the complex conjugate matrix, which is the bi-orthogonality property. So U1, and what are the lambda and lambda 2? First of all, so that's interesting. So that says I should get steady state, because all my eigenvectors are negative. That says I should get steady state, and the steady state solution is not trivial, because I have non-homogeneous term. If the non-homogeneous term is there, definitely for lambda minus 1, lambda minus 4, it is both eigenvectors are negative, they are not 0, even we can get the steady state solution. If I have the homogeneous equation, if one lambda has to be 0 to get the steady state solution, other lambdas have to be negative. Okay, so U1 and U2 the eigenvectors. What are the eigenvectors? 2, 1. Excellent. V1. What is that? 1, 1. No. 1 minus. You are correct. Okay. So now with this, so what is the solution? We have done yesterday. I won't show the steps. I just want the answer. The steady state solution. H1 SS steady state and H2 steady state. You give me the answer. 3 by 4, 1 by 4. Did you do it? Or okay, you have the steps with you? Let me see the steps, because we are doing so fast. Let me see the steps. Okay. Fine, thanks. So 3 by 4 and 1 by 4 is the answer. And then this is the steady state. Now, like last class, we have to verify the steady state, how is it achieving. So we have to get the time dependent problem. And the time dependent problem, you have to get the equation is alpha 1t, which is alpha 1 0 e to the power lambda, it gets alpha it lambda it 0 to t plus e to the power lambda it 0 to t, and then e to the power minus lambda I tau beta. With this, you can get alpha 1 and alpha 2 on it. There are two things, two items, alpha 1 and alpha 2. With this, what will you get? You will get h1 and h2 as function. And again, if you put time into infinity, you should be getting h1 as h2 as. And then you go back home and calculate. So with this, I have solved a lot of example problems. These problems you can dig out in your textbook. There is a mathematics and chemical engineering one. That book actually you can look into, and you can get a lot of such example problems. So this portion there are fairly good. There are fairly good examples in your textbook. But only thing is that calculation of eigenvalues, eigenvectors, those kind of things, teachers are not there. If you practice, you will really appreciate. Now the situation is, this is one of the approaches where we can decompose the eigenvalues and solve it. So one thing I will try to discuss, if you have, for example, dx1 dt equals to say a1 x2, dx2 dt equals to say a2 x2, and dx3 dt equals to say a3 x3. So if you want to solve, you can directly solve like this, or you can write dx bar dt, capital X bar, which is a1, a2 and a3, 0, x1, x2 and x3. Right? Am I correct? Yes or no? And then this type of thing, so you are actually having dx dt equals to ax, and this type of part we can write. So for example, what I am trying to do here, dx dt equals to ax, I showed earlier, dx by x and a dt, and we have x equals to c e to the power 80. Am I correct? Yes or no? And how to do that? You put integration here and put the constant is ln x, ln c. ln c is the constant, so x by c is e to the power 80, and you get x equals to c to the power 80. Question is similar kind of thing can be applied. So in that case, what should I write? E to the power ta. Should we write c here, or we write e to the power ta c here? What is c? Is a matrix or vector? This vector, e to the power ta. What is e to the power ta? How to evaluate e to the power ta? Situation is becoming different. This situation is very easy, but this situation is different. You are getting x e to the power ta term. How to evaluate e to the power ta? I plus then 80 s square t square by 2 factorial a cube t cube by 3 factorial and so on. Did you know earlier this kind of thing? It can be done. Where did you learn? Huh? What is that? Which course? Oh, you are doing now. Modern control theory. Okay, excellent. Very good. So that's why this kind of course you should take, so that you can actually really appreciate the application. I think these kind of things will be a tremendously apparent controls. So if you see that it is what either matrix or vector, it will say this way. So I matrix square matrix n by n. This is n by n. This is n by n because a is n by n. Multiplied by n by n should be n by n. It is n by n. So this is a n by n matrix. Okay. And now x vector is a column vector. What is that vector? n row, 1 column. E to the power ta is a matrix n by n. So you should get n by 1. Okay. How to get it? Where the c will be? Where the c will be? You see here or see there? And what is c? What is c? n by 1. So c is a vector. So this is vector, this is matrix, and c is vector. So if you write this is wrong and this is correct. Okay. So x vector is nothing but e to the power ta into c. How to calculate e to the power t? For this kind of matrix, if A is a diagonal matrix, if A is a diagonal matrix, e to the power ta will be, for this case, What will it be got TA? A matrix is given. Yes, madam, last part 1. You are nice responding my questions. Can you try? It will be got TA. You are responding nicely. That's what I am still asking question. If you don't know, you forget it. Do you know the answer? No, but nice expressions will be coming here. What will happen actually here? So this 1 plus 80 means A1, A2, A3. Then it will be, so diagonal term will be what? It will be having 1 plus A1T, A1 squared, T1, T squared by 2 factorial. So each will be the expression of exponential series if you do that. So it will be e to the power A1T, e to the power A2T, e to the power A3T. Pardon? Not lambda 1 here, this A1, A2 and A3. So it will be e to the power A1T, e to the power A2T and e to the power A3T 0, 0. Which is excellent result if you have a diagonal matrix. If you don't have, difficult to calculate. If A is not diagonal, if A is not diagonal, e to the power TA is difficult to calculate. Which is not there in your textbook because it is difficult. But syllabus it is there. That's the problem. So e to the power TA, which is and most of the matrices are not diagonal, right? Most of the matrices we have seen just now. So many problems we have done. None of the matrices is diagonal. The thing is that it is possible to. Now there is a good news. The news is it is possible to reduce many matrices to diagonal matrices. Bad news is some matrices you cannot put to diagonal matrix. So good news is some matrix you can convert to diagonal matrix so that you can apply directly. You don't have to do all those eigenvalue expansion. Directly you can find eigenvalue, get the answer, go home and sleep. But if the bad news occurs, that means you cannot diagonalize. That means even if you can want to reduce, some of diagonal terms are coming, then this method will not be valid. You have to go for the different methods. And sometimes what actually happens, what is my opinion, if the method is not diagonalizable, I will not go for the entire procedure of diagonalizing. What I will do, directly I will go by this method and try to find out some of the good ways to evaluate this e to the power t. So this is my very important matrix and which is called as fundamental matrix. 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 Okay. This fundamental matrix, it is not there your textbook. Maybe you can look at differential equation on book by Dew and Raghavendra, the mathematics book. You may try to look at the book. I don't know offhand because this is generally the advanced level mathematics. Of course, you are doing advanced level here, so that is included in the syllabus. But your textbook definitely doesn't have all this concept. Textbook has very good limitation because textbook talks about only distinct eigenvalues. And this covers the entire spectrum. Your eigenvalues are repeated, non-symmetric matrix, you will get generalized eigenvectors, so many things, and all those things, this fundamental matrix will cover. It is like what for a set of differential equations. So we will be addressing this part in this course. At the end of this entire spectrum of this PhD equals to X will be, in fact, when you know how to evaluate the part TA, then you will directly go into this direct method. So if you do this, so this is basically called as direct method. Because you don't have to go for eigenvalue decomposition, you know the answer. Your job is to find out the C. If you know the C vector, job is done. You got the solution. If you got TA can evaluate it because A matrix is known, and there are ways to evaluate the TA. So this kind of entire things will be addressed in the next couple of lectures. Let's look at So our first step is, we will go step by step procedure. Our first step is to convert a matrix to a diagonal matrix. First step is to convert a matrix to a diagonal matrix. First step is to convert a matrix to a diagonal matrix. First we will be talking about the symmetric matrix. First we will be talking about symmetric matrix. So we know that symmetric matrix is guaranteed the eigenvectors of the world, even the different eigenvalues. Okay? So our mother system is dx dt equals 2x. We have to convert a system this is my objective. What I want to do, I will convert. This is my diagonal matrix. This is my diagonal matrix. What I will do, this is the original system, dx dt equals to x, such that I will do some operation here and I will get dy dt equals to lambda into what? Lambda, big lambda. This is called the Greek letter. You have English letter. We write capital A. We write small. For Greeks, it is capital lambda, small lambda. Okay. So, in fact, when the Greeks talk, it will be very, very complicated because we are using alpha, beta, gamma, delta, and I had the opportunity or fortune or whatever to work under a Greek person during my postdoc, and I used to listen when they were talking in their own language. It is very difficult to understand what they are talking because all the time they will be talking in terms of alpha, beta, gamma, psi, kappa, all those things. So that's the Greek letters. Okay. So the objective is we have to convert dx dt equals to x to dy dt equals to lambda y. Remember that A matrix is not diagonal. The matrix A matrix, in fact, the numerical problems what we did, it was not even symmetric, it was non-symmetric system. Okay, but definitely for all the cases we got distinct eigenvalues. So those problems can also be solved by this. I will come to the second part, non-symmetric matrix. First we will be talking about symmetric matrix. But the objective is to convert this to a system where the matrix A will be transformed to a diagonal matrix that is called as lambda matrix. In order to do that, I will start with define a new matrix called P matrix. I will define a new matrix called P matrix such that each column of this matrix would represent the eigenvector. So my eigenvectors are first eigenvector u1, second eigenvector u2, and it is u3. Right? Each of these columns are the eigenvectors. That means if you want to write in terms of eigenvector notation, it is u11, u12, and u1n, u21, u22, u2n, and similarly un1 and un. So this P matrix consists of all eigenvectors. It is possible to find out eigenvectors. We have seen it. Now we are really expert in finding out the eigenvectors. It is possible to find out the eigenvectors. So with that, it is possible to construct the P matrix. It is possible to construct the P matrix. Okay. Now if you construct the P matrix, it is possible to construct P transpose. It is possible to construct P transpose. What is my P transpose then? Here, each column is actually representing the eigenvector. In P transpose, each row will be representing eigenvector. So, very simplified way, you can write E11, U12, and U1n, U21, U22, U2n, and we have UN1, UN2, and UNn. So two matrices can be easily constructed. What is P matrix and P transpose matrix? What is this P transpose matrix? What is this P matrix? Any special property you can guess? am constructing this P matrix, what is the beauty of this matrix from the property of matrix perspective? What is the beauty of this matrix? I have certain eigenvectors. I am constructing P matrix. What is the philosophical perspective of this P matrix? Pardon? Yeah, you are telling something. Yes. You are telling something. Diagonal elements are same. How is it possible? These diagonal elements are same? Yes. How to prove it?
P transpose into
P. Okay, very good. Thank you. Let's see. P transpose into P transpose into P. How to get the first and row? This is a multiplication of two terms, and I have told you the rule of multiplication. First row, first column. First row, first column. First row, first column. What should I write? In a compact form. First row, first column. Excellent. Very good answer. Inner product of this. Right? Second. First row, second row. Sorry, first row, second column. Inner product U1, U2. Because symmetric matrix, all the eigenvectors are orthogonal, inner product U1, U2 equals to 0. And it will go to all the points 0. Similarly, you have inner product U2, U2, 0. You have final term inner product UN, UN. Okay? So P transpose P, we are getting a matrix which is not identity matrix. So whatever you say, the P transpose P is orthogonal matrix which is not exactly correct. Why orthogonal matrix property is P transpose equals to P inverse. It is not guaranteed from it. It is some matrix. In fact, inner product U1, U1 may not be inner product U2, U2, may not be inner product UN, UN. So definitely it is not P inverse, but there is a chance. But there is a chance. When is a chance? Yes, exactly. If the eigenvectors, what you are getting, they can be made orthonormal. That means length of the eigenvector is unity and it represents the square of the length. And each of the length is unity. That means it will be identity matrix. Then P transpose equals to P inverse. So for the symmetric matrix, you found very interesting matrix, which is a P matrix, such that this matrix P could be orthogonal matrix provided eigenvectors are orthonormal. Provided eigenvectors are orthonormal. But if you don't have orthonormal eigenvector, what you do? Many of the times, all these problems, you could see that eigenvectors are not orthonormal. You saw the eigenvectors, right? 1, 1, for example. 1 minus 2, this kind of eigenvector. If you do the square root, 1 plus square plus 2 square, then root 5. It is not orthonormal. This length is not unity. What we can do in that case? Gram-Schmidt you can do, but if I don't know Gram-Schmidt, let's see. What is the difference between P transpose and P inverse? That's very interesting. What's the difference and how to get any kind of relationship of that? So I will show you that without doing Gram-Schmidt, you can do something. So let's see. So I want to play around with matrix now. So my job is to just play around with P matrix. I like it. So let's look at how to play with this P matrix. It's a very nice matrix. This P matrix has a lot of interesting properties. So if you look at P transpose P, which is a diagonal matrix, do you agree or not? Okay, so we're getting some clue now. P transpose P is diagonal matrix. So that could be one of the catch to start the problem. So from here, can you find out P inverse? no inner product. Inner product is difficult at this point. Without inner product, we can get the answer. P inverse in terms of the node quantity is given here. P inverse equals to, yes, something you are saying. Huh? No, I want the final answer. Pardon? 1 by determinant. No, what stories you are telling? See, we have seen this kind of thing. A B equals to C. If I want to see B is what? It is nothing but A inverse C. This kind of transfer I am meaning to. Why you are going so complicated? This kind of things have been learned, in your school level. What is that? No, I just want to have the answer. P inverse equals to what? There are so many things you are telling. I want the cute answer. Yes, sir. Huh? So much of things you are telling. It's very cute answer. What something you said? Yes, such a simple answer she gave. Thank you. Such a simple thing. You are doing so much of research. Mathematics is not complicated, very simple. Lambda inverse P transpose. Okay? And then, if now we can see that if lambda is identity matrix or lambda is the matrix such that, so lambda inverse could be such that P inverse equals to P transpose. It could be possible. So lambda inverse could be such that P inverse equals to P transpose. Okay, so now we want to verify what is this lambda inverse P transpose matrix. Because so far we have got P and P transpose. We have not got P inverse. We need P inverse. Without P inverse we cannot do anything. And getting P inverse looks like very difficult, right? So we have to take determinant, cofactor and all those things. Very difficult. Let's see from if you can evaluate lambda inverse and P transpose, you can get P inverse. Then why do you do so much of juggler? Lambda inverse will be how much? So this I am saying this is your lambda matrix, right? Am I correct? This is your lambda matrix. If a matrix is diagonal, inverse will be what? If the matrix is diagonal, what will be the inverse matrix? Matrix 1 by these things. Okay. So it will be inner product U1, 0, 0, inner product U2, 0, and last you get inner product UN. Okay? And then P transpose is already there, which is U1, 1 to UN1, U2, 1 to U2N, and you have UN1 to UN. These two matrices, if you multiply, you get P inverse. Simple. If you multiply this, what you get? If you multiply this, what will you get? We delete this part. You get confused. U1, 1. Inner product U1 bar U1. Next.
Next is the diagonal.
U2 U2 1 by again inner product, and then you have UN1 by. Am I correct? Yes or no? Yes. This is obtained by this is the first row, second column. Right? First row, second column. First row is this. Second column is this. Okay. So only this first entry will be multiplied, other entries are 0. Right or wrong? Similarly, it is U21 inner product, U2, 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 2, inner product, U2, U2, and you have UN2, inner product, U2, U2. That should be always constant. And similarly, you have UN1, UN, UN, and you have UN10 divided by inner product of UN, UN vector. So we have found finally P inverse matrix. Remember that P transpose and P inverse are not same. They are completely different. P transpose was what? These terms will not be there. And of course you can see that in orthogonal matrix, this will be all 1. P transpose will become P inverse. So it has been again proved where P transpose equals to P inverse is if the matrix is orthonormal. Orthonormal means all lengths are 1. And this will become P transpose and this is also P inverse. But most of the cases we won't do orthonormal. The question is, instead of will you do all the time the Gram-Schmidt or without Gram-Schmidt you can do it. Let's look at it. Yes.
Is it equal to 1 upon internal product of the internal product?
What you do?
If you take this common, the internal products common, U1, U1 from the rows, you will get, but you will see that. You will get it. You will get it, but no, the thing is that this is the situation right now. This is the situation right now. Okay? So we don't know what is going to happen. So next thing I am going to discuss, so how to do dx dt equals to ax conversion. I want to convert to a diagonal matrix. I want to convert to a diagonal matrix. Okay? So to do that, we will have dy dt equals to lambda into 1. How to get this lambda? So, to again, because I wrote that to remind you, you have to get that. And in fact, P transpose P is not coming here directly. So, there is a transformation. I am going to show it. To show P inverse AP equals to lambda. To show that P inverse AP equals to lambda. So, what is P inverse AP then? First we will talk about AP, then we will talk about P inverse. What is A matrix? A matrix can be written as A matrix into P matrix, which is having the eigenvectors U11, U21, U1n, U21, U22, U2n, UN1, U2. That is the way I can write. These are eigenvectors. So each matrix and if the row, this row, if I multiply, this column if I multiply, you will get lambda 1 U1, lambda 2 U2, lambda n U1. So you can also write this as A U1, A U2, A U1. So in P matrix, you can actually write lambda 1 U11, lambda 1 U12, lambda 1 U1n. Similarly, you can write lambda 2 U11, sorry, U12, lambda 2 U22, lambda 2 UN2. Similarly, you can write lambda n UN1 and we have lambda n UN. AP matrix. P inverse AP. how to write P inverse matrix known to us? What is P inverse matrix? Remember that P transpose is known, and for P transpose the rows will be divided by the square of the length of the vector. That means first row will be divided by u1 u1. If you look at the notes, second row will be divided by u2 u2, third row u3 u3, and nth row will be u n u. Right? So P inverse AP, the P inverse matrix is known, which is u1 1 inner product u1 u1, and we have u1n inner product u1 u1, and last will be un1 inner product un un, and last will be unn inner product un un. AP matrix is given, which is lambda 1 u11, lambda 1 u1n, and then we have lambda n un1, and we have lambda n un. P inverse AP, this is the AP matrix, the P inverse. If you multiply, what you see, this. Okay. So u11 is common. Okay. And you are essentially multiplying this row vector to column vector, and that vector is u1 vector. So it is lambda 1 u1. So it is lambda 1 inner product u1 u1 divided by u1 u1. This will be this by this, automatically 0. All 0. Similarly, it is lambda 2 inner product u2 u2 divided by u2 u2, 0 0 0. Again we have lambda n un un divided by un un, and which is coming as a matrix, cube matrix, lambda 1 lambda 2 lambda n. So P inverse AP has become a diagonal matrix whose diagonal entries are the eigenvalues, whose diagonal entries are the eigenvalues, whose diagonal entries are eigenvalues, whose diagonal entries are eigenvalues, whose diagonal entries are eigenvalues. Okay. So, but and if you look at P transpose AP, what is actually happening? So it doesn't matter that P inverse equals to P transpose. Okay, it doesn't matter. If P inverse equals to P transpose, these entries will not be there. Okay, and then you can directly write this step, and this is equals to 1 because of the orthonormal set. But now, if it is not orthonormal, this gets cancelled. This gets cancelled. So such a beauty. So it doesn't matter whether your eigenvectors are orthonormal or not. P inverse AP is always a diagonal matrix, and diagonal entries are lambda 1 to lambda n. Diagonal entries are lambda 1 to lambda n. Okay. Diagonal. So our new diagonal matrix. This do not get confused with the earlier lambda sign. So new diagonal matrix which is lambda, just lambda 1, lambda 2, lambda n, all 0. So now what we are going to discuss here, the steps are very simple. We have x, multiply both sides by P inverse, dx dt equals to P inverse Ax. What you do next? P inverse dx dt is keeping it same. We can write P inverse
AP, P inverse X, because identity matrix I always introduce anywhere. So this is your lambda, and this is your y vector, and this is your y vector. Y vector is nothing but P inverse X vector. So if you solve it, what's the y vector? The y vector will get e to the power lambda t into c vector, right? And then if you know y vector, how to get x vector? Multiply by py, multiply by p. If you have the p, py equals to x, so p e to the power lambda t c is your answer. Okay? So directly you are getting solution without doing this alpha 1, alpha 2, alpha 3 business. Is this concept clear to all of you? Yes or no? Any confusion here? Any doubts? So that's not why. So one thing I want to stress here that we don't need P transpose here. Our important part is P inverse. Because of inverse only you could do this. If you know P transpose, it won't be helpful because P transpose may not be equal to P inverse. And we don't need to know orthogonal set of eigenvectors. We can get orthogonal set of eigenvectors. And with orthogonal set of eigenvectors, it is possible to get direct solution by the. And this transformation is known as similarity transformation, and this matrix was known as similar matrix. This is known as similarity transformation. And in that case, why it is called similar matrix? Because A matrix can be written as P, right? A matrix. So this matrix are called as similar matrix, and this entire transformation is known as similarity transformation. This entire transformation is known as similar transformation. Am I clear? Yes or no? Did you find out how to prove it? You post multiply by P inverse, so it will be P inverse A, lambda P inverse, multiplied by P, it will be A matrix only, it will be P lambda P inverse. This is all the game with matrix. So that's why these two matrices are called as similar matrix. So now one interesting thing is that any matrix, but any matrix cannot be diagonalizable. If I give any matrix, you cannot say I can diagonalize, provided you have to see the eigenvalues of the matrix. So very interesting. Depending on the nature of the P, just like that any P will not give this property. That P is such that eigenvectors are orthogonal and eigenvectors are actually resulted from the distinct eigenvalues. The question is, if you have non-symmetric matrix, in that case what actually happens? In that case, for distinct eigenvalues, you get linearly independent eigenvectors, and with Gram-Schmidt orthogonalization or orthonormalization, you get orthonormal eigenvector, and you can still use for non-symmetric matrix. But the question comes, if the matrix is not having distinct eigenvalue for non-symmetric matrix, and there is a chance to get generalized eigenvector, in that case what to do? That's the question. And the next class I think we will be having tomorrow 4:45 to 2 classes, because Friday there is no class. So tomorrow we have the exam, and the exam will be MSB 355 and 356, 2 rooms. You can talk to TS will give you the roll numbers. I think first set will be going, first 34 people to MTech, MSB 355, then first 34 onwards to MS PhD, all will be coming to MSB 356. These are all the sitting arrangement. Exam is 8 o'clock, and we have the class from 4:45 to I think 1.5 hour, our usual slot. And Friday no class. Another good news is Monday also no class. So if you can attend tomorrow's class, you are free till Monday. Next, after that we will be meeting on Tuesday. Thanks for your attention.